Hey everyone, how goes it? And welcome back to Computer Science 145. Today, we're going to continue to discuss arrays. As mentioned in a previous lecture, an array is a collection of variables of the same type. This is a foundational data structure, and it is a contiguous block of memory. Furthering this concept, arrays can have multiple dimensions. The way that we can accomplish this is by simply using more of the square brackets. In this class, we're only going to focus on two-dimensional arrays, but you can have more dimensions as you see fit. In order to create a two-dimensional array, you do it in a similar way. First, you use the type followed by two square brackets and then an identifier. After that, we construct this by using the type, and then within the two square brackets, you put the two different sizes of this array. If we needed to create a 2x3 array of integers, then we just use the type int, two square brackets, the identifier, then new int, followed by 2 and 3. Now, as Java considers arrays to be these container objects, whenever we create multidimensional arrays, you can think of this as being an array of other arrays. Always keep in mind that the identifier of an array references a memory address. This memory address references the contents of the array. This means that you might have an array that simply has memory addresses to other arrays. Looking at this in memory, we can consider it like this. Following this statement, if we arrive right here, we understand that this declares the array. So over here we have the identifier array, and currently its contents is null. Because remember, this is going to contain the memory address to the contents in the array. When we get to this part, we're now constructing an array of size 2. But now notice that the contents inside of memory are also both null. Now this is because in the next step, we construct two three-dimensional arrays. Here's one three-dimensional array, and here's another three-dimensional array. Now just like before, this is going to contain the memory address of this three-dimensional array. This is going to contain the memory address of this three-dimensional array. So the way that you can think about this, array at index 0 will be assigned to the memory address 100. An array at index 1 is assigned the memory address 150. This is the start of the first array. This is the start of the second array. Now, once that's assigned, you can consider those to be pointing to these two separate arrays. Now, furthermore, the original identifier array is then going to get assigned to memory address 60, in other words, the first address that's right here, and you can consider this to point to this start of the array. This creates an array that has 2 by 3 elements. Once again in Java, you can consider multidimensional arrays to simply be arrays of other arrays. Indices for multidimensional arrays work in the exact same way. We always start at index 0, and the last valid index is the size or the length minus 1. Whenever we're indexing into multidimensional arrays, we must make sure that we index for each one of the dimensions. So over here, if we needed to access the data, then we need the identifier followed by the first index in the square brackets and the second index in the other square brackets. Now similarly, if we're bonifying information, then we need the ID followed by the first and second index and assign that to whatever the value is. The more dimensions that you have, the more indices that you have to worry about. Now, the length property works in the same way, but do remember that you might have different lengths. Like, if you want to consider the id.length here, this will be the size of the outside dimension of the array. And then, if you take the id and pass in one of the indices here and call .length, this will be the size of the inside dimension of the array. In our previous example, this one would be 2, and this one would be 3. Also, much like before, the for loop is an array's best friend. Now, for a multidimensional array, nested for loops are the array's best friend. Let's take a look at a quick example of that. Now, we can absolutely consider the memory to more or less be like this, but for simplicity's sake, let's take this two-dimensional array and make it look more like this. What we have here are the indices, and what I usually consider is the j element to be the horizontal aspect and the I element to be the vertical aspect. So in this for loop, you have the index I here. This is going to correspond to the vertical part of the array, and you have this index j here that's going to correspond to the horizontal part of this array. Let's run through this example and see what happens. Starting at the for loop, we create int index I. Now, the way that we can visually think about this is we start right here, index 0 for I. I is less than array.length. Now, this is corresponding to the outside part of the array, the vertical part. So we have 1, 2 elements here. 0 is less than 2. Now we enter the body of that for loop and start with index j. And we can consider this to be pointing to right here. J assigned the value of 0. Now we have to look at this. J is less than array at index I. In other words, array at index 0.length. So this size is 1, 2, 3. Now notice this. If we were to omit this index right here, then we may run into a logic error. Because here's the thing. Array.length was 1, 2. However, for this horizontal part, we have 1, 2, 3 elements. It's important to use this. That way we make sure that we have the correct sizes corresponding to each one of the dimensions. Now, entering the body of that for loop, array at index I at index j is equal to simply I plus j. So 0 plus 0 is assigned here, and it's just 0. Then we increase j by 1, and you can think of that as just simply moving over. Now 1 is less than 3. So we enter the body of this again, and then we add 0 plus 1, which is 1. We increase j by 1, which moves it over here. 2 is less than 3, so we enter the body here, and we add 0 plus 2, which is 2. Now we increase j again. J is now 3. 3 is not less than 3, so we're done with this for loop. And now we have to continue with the outside for loop by increasing I by 1. When we increase I by 1, we now move inside of here once again, and we're going to repeat the same procedure. And as you could probably guess, the next indices is 1 plus 0, 1, 1 plus 1 is 2, 1 plus 2 is 3. So a few steps later, we end up with this type of array. Now once again, for simplicity's sake, we only represented this two-dimensional array in this way. But you may consider the memory to more or less look like this. where you have array at index 0, 0 is assigned to 0, 0, 1 is 1, 0, 2 is 2, and then array 1, 0 is 1, 1, 1 is 2, 1, 2 is 3. Now let's see an example of a multidimensional array. What we're going to do is create a game, and we're going to just play a game of hide and seek. In this game, we have a game board, a two-dimensional array. Let's say that we put the player right here. And then we randomly select a goal position, and let's say it's right here. Now, as this is hide and seek, we need to hide that position, so it goes away. We allow the player to move around this board in 8 directions: up, down, left, right, and diagonally. Every time the player moves, we leave behind a marker showing where they have come from. So as they keep moving, we keep leaving behind those markers showing a walked path. Now, in order to help out the player, we're going to indicate how close they are to that goal position. If the player is more than half of the board away, we indicate that they are getting colder. If they are between 1/4 of the board away and 1/2 of the board away, then we indicate that they're getting warmer. And if they are less than 1/4 of the board away to the goal position, then we say they're getting hotter. We allow the player to move around this board, but we also make sure that the player can stay inside the bounds of the board. So let's say that they were at this position right here and tried to move down. Well, that's outside the board, that's invalid, so all we do is just make sure to contain them within the board. Once the player has reached the goal position that was randomly selected, we say that they win. Now, let's see that inside a code. Now we've already set up our project, so the next thing that we're going to do is create our class, and we're going to call it hide and seek. Include the main method. We're going to go ahead and take out that auto-generated comment and make sure we put our name at the top here. Now before we start, there was a couple of things that were mentioned in the project description. First of all, the player needs to be able to interact with the game, so we need some form of user input. So we're going to import java.util.scanner in order to have some form of user input. We also mentioned that the goal position was going to be randomly selected. So we're going to also import java.util.random in order to use that type random. Now, outside of the main method, we're going to create a couple of constants that's going to be used. In the description that we showed, we had a board size that was 10 by 10. So we're just going to create a constant for that. Public static final int board size, and just assign it to 10. Now, as the board size is fixed, we also mention these distances that we need to calculate in order to indicate if the player is getting colder, warmer, or hotter. I'm going to go ahead and define these now also as constant values. Public static final int. We'll call this the cold distance, cold dist. And we're going to create this as the board size divided by 2. But we're not quite done there, because we're going to use a version of the distance equation in order to calculate whether or not they're warm, cold, or hot. So we're simply going to square it by doing this, board size divided by 2. So effectively, this makes half of the board squared. We'll go into more detail about why we do this in a little bit. The next one, public static final int, the warm distance, is equal to the board size divided by 4, because this was 1/4 of the distance, times board size divided by 4. Now, we're not going to make the other distance, but we are going to create a couple of more constants. We haven't created this board yet, but we need to think, what kind of type will we create in order to display this kind of board? We can choose a lot of different types, but to keep things simple, I'm going to say that this is going to be a two-dimensional array of characters. Now, with that being said, there were a couple of different spaces. Like, for instance, one space on the board could indicate that it is empty. So let's define that. Public static final character. Let's say this is the empty space, and we define this as the underscore. Now we also need to indicate where the player is. Public static final character player, and we'll just say it's the X. Now we also want to indicate where they have walked from. So let's create a public static final character walked path. And let's assign that to the pound symbol. And for debugging purposes, I'm going to create public static final character goal. And I'm going to assign this to the underscore. Now notice that the goal position, the goal character, is the same as the empty. The reason why I'm doing this is in case there were some problems with some of our code, then what we could easily do is assign this to a character to help us debug what could be going wrong. However, for argument's sake, what we're going to do is keep this the same thing as the empty character. That way the player can't see where the goal is. It's the hidden position. Now, entering inside the main method, we're going to go ahead and set up the user input. Scanner keyboard equals new scanner system.in. That way we can read from the console. Next, we're going to create the random number generator. Random R equals new random, as we need to select the random goal position. Now, once we've done that, we need to basically figure out where the player is going to go on the board. And we need to keep track of where that player's position is. For argument's sake, we're going to use the indices for the multidimensional array in order to keep track of this. So if we're going to assign the player to the top left position, what we need to do is assign int px, its x coordinate, to 0, and also int py is also equal to 0. Now we need to randomly select that goal position. Int gx. The goal's x position is equal to r.nextInt. Now, to make sure that this selects an integer that's within our board, we're going to pass in the constant board size. Now we're going to do the same thing for the y. Int gy is equal to r.nextInt, passing in the board size. So once again, this version of nextInt selects a value from 0 to this value exclusively. So in other words, this will select a value from 0 to 9, which is valid. Now that we have that, what we're going to do is create the board. As mentioned before, this is going to be a two-dimensional array of characters. So we start out with the type, character, and then we put 2 square brackets. This 2D array is going to be called board. And we're going to construct this as a new character array of board size by board size. So this creates a 10 by 10 array of characters. Now that we have created the board, we need to assign each one of the characters to this empty character. The best friend of an array is a for loop. The best friend of a multidimensional array is nested for loops. So we're going to create for int I is equal to 0. I is less than board.length I++. Now, for argument's sake, we're always going to correspond I to be the vertical aspect of this array. Now we also need to create for int j is equal to 0. J is less than board at index I. Dot length j plus plus. Now we have this index I, which is the vertical part, and this index j that corresponds to the horizontal part. This is where we can now assign board at I, the vertical, j, the horizontal, is equal to empty. So now what this does, these nested for loops, it assigns every character inside of this two-dimensional array of characters to the underscore. And once again, the underscore corresponds to an empty space. Now that we have created the board, and we have made sure that all the spaces are empty, we should now place the player on the board. So once again, we use board. Now, the first index should correspond to the vertical part. We have the coordinates x and y here. Now the y is going to correspond to the vertical part, so we're going to use py. Followed by px, the horizontal part. Now we assign this to be the player. Thus basically, we put this x at 0, 0 initially. Let's do the same thing for the goal. Board at gy, gx is now assigned to the goal character. Now right now, goal is the same character as empty, but if we needed to debug this, then we could simply assign this to, I don't know, like an O, to see exactly where it is. That way we could figure out what could be going wrong. But for now, we're going to just keep that as the underscore. That way we hide it. Now that we've established all of this, let's go ahead and prompt the user. System.out.println, welcome to hide and seek. Then we're going to create the game loop. Boolean game over. We're going to set that equal to false. And while not game over. So while we have not found that goal position. Well, before the user can enter anything, we really should show the board. So we should print out all of the characters on that board. Well, printing out is just a way that we can process this data. And once again, we're going to use nested for loops in order to print out the board. So for int I is equal to 0. Again, this is the vertical part. I is less than board.length I++. Now for each vertical part, we're going to correspond the horizontal part by using for int j is equal to 0. J is less than board at index I dot length j++. Now this for loop right here, inside of this body, we should print out all of the horizontal characters. So we're going to use system.out.print, not print line. We're just using print, that way we don't skip down a line. Inside of its arguments, we're going to print the character found at board index I and index j. Now after we've printed out all of the characters horizontally, we need to skip down the next line, in other words corresponding to this vertical part. So outside this inner for loop, but inside the outer for loop, we system.out.print line. That way we skip down a line. Now these for loops simply just print out the board. We also should indicate to the user whether or not they're far away, kinda close, or really close to that goal position. So what we need to do is calculate the distance, and we're going to use a modified version of the distance equation. To keep things simple, we're not going to take the square root. We're going to always assume the distances are squared. This is why at the top here, we simply squared each one of these distances. And we're going to do the same thing down here. First, we're going to calculate int distance is equal to the px minus the gx, the player's x position and the goal's x position. And easily enough, we just multiply that by px minus gx. Now we add together py minus gy times py minus gy. Now the reason why we did this once again is that way we can just avoid using a square root. If we just square all the distances, then we just consider the distances to be squared. Now going from there, we need to evaluate how close they are. If this calculated distance happens to be greater than the cold distance, then they are more than half of the board away. So then we say system.out.println, you are getting colder. Now, if this expression evaluates to false, that means they are less than or equal to this cold distance. But now we need to check else if the distance happens to be greater than the warm distance. Now, if this distance is not greater than the cold distance, however, if this distance is greater than the warm distance, then easy enough, system.out.println, you are getting warmer. Finally, if this evaluates to false and also this evaluates to false, then they must be less than or equal to that warm distance. So we're going to say system.out.println, you are getting hotter. We only needed the cold and the warm distance because using this type of branching statement, we can evaluate whether or not if we're very close. Now, once we've done all of that, printed out the board, calculated the distance, told the player how close they were, now we are ready for the user input. So we're going to do it in this way. System.out.println. Enter either -1, 0, or 1 to move in the X. We're going to create a new variable, int dx. The delta x is equal to keyboard.nextInt. Now we're going to do the exact same thing for the y, and we're going to create an int dy, delta y is equal to keyboard.nextInt. And keep in mind, when I'm referring to delta, I mean the change in x and the change in y. Now, just like before, we need to validate if these inputs are correct. The only valid ones are -1, 0, and 1, so we need to make sure that the change in x and the change in y are these three values. Here's how we're going to do that. If dx is less than -1 or dx is greater than 1. Now, this would be outside of that range. If that's the case, then we'll say system.out.println, that is invalid. And for argument's sake, we're just going to reassign dx to be 0, so no change. Now we need to do the same thing for the y. If dy was less than -1 or dy was greater than 1, once again, we say that's invalid, and we assign dy is equal to 0. Now there's a little bit of subtlety right here. Notice, we have this if statement followed by this if statement. Would it be incorrect to make this one into an else if statement? I would argue that it would be incorrect to do that, because this value does not depend on this previous value. These should be independent checks. If I were to create this as an else if, the only way that this Boolean expression would be checked is if this one were true. So in fact, what we might have is a valid x position, but an invalid y position. These are two different checks. they should be independently checked. So do not put an else if here. You should only use an else if that current Boolean expression depends on the value of the previous Boolean expression. They are dependent. Now that we've validated the input, here's what we're going to do next. As we are moving around the board, we're going to indicate where we just moved from. So using the 2D array board, we're going to take the player's Y position, because once again, this index corresponds to the vertical part, followed by the player's X position, the horizontal part, and we're going to assign that to the walked path. Now this is where we previously were. Now we have this change in X and change in Y, so we need to update the X and Y. So Px plus equals dx and Py plus equals dy. Once we have updated the player's X and Y coordinates, what we do need to do now is make sure they're still within the bounds of this board. This is a form of collision detection. So let's check. If Px was less than 0, that means they've gone all the way to the left and outside the board. Then what we need to do is reassign Px back to 0. Now we're going to use an else if. If the Px happens to be greater than the board size minus 1. Remember, the board size minus 1 is the last valid index on this board. So in this case, what we need to do is reassign this to Px equals the board size minus 1. So this check right here makes sure that if we go all the way to the left, that we don't go out of the bounds to the left. And this one checks if we go all the way to the right, that we don't go out of bounds to the right. I used an else if here because this does depend on the other one. It cannot be both. Both of these cannot be true at the same time. Now we do the exact same thing for the Y. So now we make sure that the X coordinates do not go out of bounds and also the Y coordinates do not go out of bounds. Now after all of that, let's finally move the player. Board at Py, the Y coordinate, at Px, the X coordinate, is simply equal to player. Now once we have moved the player, let's check if the game is over. So if the Px is equal to the Gx, the player is now on the same coordinate as the goal, and because both have to be true, player's Y coordinate is the same as the goal's Y coordinate. If both of these are true, system.out.println, you win. And game over is equal to true. This is a lot of code to make a hide-and-seek game, but now let's see if it works. Now running it, here's our board. I'm going to expand it a little bit. Here we go. Here's our board, and as you can see, the player's right there. So we're pretty cold, so let's move diagonally. I'm going to enter 1, followed by 1, and look, we move diagonally. Okay, we're still getting cold, so let's do 1 and 1. Still cold, 1 and 1. Okay, we're getting warmer. Let's keep moving diagonally. 1 and 1. Okay, 1 and 1. 1 and 1. Ooh, we're getting colder. Okay, hold on a second. Let's move 0 and -1 to move up. Okay, we're getting warmer. So 0 and -1. Still getting warmer. 0, let's see, -1. Okay, getting warmer. 0, then -1. Okay, we're getting hotter. So let's keep moving up. 0 and then -1. Okay, 0 and -1. Oh, okay, hold on a second. Now, let's move 1 and 0 to move over. 1 and 0 to move over. 1 and 0 to move over. Okay, still not there. All right, 0 and 1 to move down. Okay, let's move over. -1 and 0. All right, -1 and 0. Ah, and that's where we are. The goal position was right there. And that ended the game. Now, before we finish out multidimensional arrays, there's a couple of more things that we need to discuss. Much like a single-dimensional array, you can declare and initialize all the values in a multidimensional array by using the curly braces. The way that you could do that is basically you have these curly braces, that's the outside container, and then for each one of the inside containers you have the values. So if we wanted to create the array that we were using before, we can create this 1, 2 by 1, 2, 3 array. And once again, here were all the values that we assigned in those previous examples. And finally, Java allows multidimensional arrays to have different sizes at each dimension. This is referred to as a ragged array, and not all programming languages support this. So looking at this example, we can create this two-dimensional array that we call A, and then we can create the outside dimension as 3. So in the first one, we have 3 rows, and in the first row, we have 5 elements. Second row, we have 8 elements, and the third row, we have 2. Java allows this as multidimensional arrays are considered to be arrays of other arrays. This is why it's very important to use the ID at this index.length, because as you can see now, each one of these have different lengths altogether. In this lecture, we have discussed multidimensional arrays. And with all that being said, I'll see you next time.